This is NNI Bites, Big Learnings, a podcast where fellow healthcare professionals converse about the latest on nutrition science. Join us as Renan Shamir and Julie Mennella share their knowledge and insights on biological and experiential factors that impact the acceptance of complementary foods.
Welcome to our podcast, NNI Bites, Big Learnings. My name is Renan Shamir, and it's my great pleasure to welcome Professor Julie Mennella from the Monell Chemical Senses Centers in Philadelphia, USA. Professor Mennella obtained a PhD from the Department of Behavioral Sciences at the University of Chicago in the US. She conducted postdoctoral studies and then joined the faculty at the Monell Chemical Senses Centers in Philadelphia in 1990, where she is now a member. She is an internationally recognized speaker on the development and function of the flavor senses, early nutrition programming, and the effects of maternal diet on lactation, publishing more than 250 scientific articles and chapters. Her research, which has been funded by grants from the National Institute of Health since 1990, focuses on how people differ in flavor perception, including how to measure it in children, and she has paved the way for dietary interventions and medicines tailored to fit individual variations, improving the health of children and their mothers. She was recently recognized by the Association of Chemoreception Sciences with the Max Mosel Award for Career Achievement in Chemosensory Research. So it is an honor for us to have Professor Mennella, a world leader in her field, with us today. So Professor Mennella, today we are discussing your paper on biological and experiential factors that impact the acceptance of complementary foods, which appears in our latest issue of Annales Nestle. Would you like to say a few words to our audience before we begin?
Well, I'd like to thank you for the opportunity to share some of the science on how babies learn about foods and perceive their sensory world. So thank you for this opportunity.
Thank you as well. So now your paper is part of a series on complementary feeding and future health. And our hope is that many of our listeners will enjoy our podcast and your paper and be able to use the information to improve children's health. In the introduction to your article, you lay the ground to the scientific evidence on how the biological substrates underlying flavor interact with early experiences to modify children's acceptance of complementary foods, which mean food other than human milk. So before we dive into flavor, can you elaborate on what is the definition of flavor?
I'd be happy to. Flavor is the sensory impressions that you experience when you're ingesting a food or a beverage. It's the perception that arises when the brain receives information about the food's taste, its smell, and other sensations like the coolness of mint or the spiciness of chili peppers. I'd like to note that you often think of smelling foods when you inhale an odor, but where they then travel up the nose and reach the olfactory receptors high in the nasal cleft. But you really are doing a lot of smelling, and you may not be aware of it, but the odors of foods reach these receptors when food is in the mouth by traveling in the back of the mouth. Often foods taste different when you have a bad cold. The reason is not due to your taste receptors, but rather the blocking of olfactory receptors due to nasal congestion.
Okay, so it seems that at birth, chemical senses are more mature than other senses. Are these senses developed already during pregnancy, and are they fully shaped at birth?
The senses of taste and smell are functioning in utero, and the baby is beginning to learn about flavors at that stage. The fetus near the last trimester is swallowing quite a bit of amniotic fluid, and they're learning about the flavors that get transmitted from their mother's diet into amniotic fluid. But the baby is not a miniature adult because these senses continue to develop during infancy, childhood, and even adolescence.
Okay. And in your paper, you describe the various tastes, sweet, umami, sour, bitter, and salty. Could you give us a few important messages on the ontogenic changes in the basic tastes?
I'd be happy to. There's a small number of classes of perceptual experiences for taste, as you mentioned, each of which special really gives you crucial information about nutrients, about dangerous substances, and it probably likely evolved because these senses are very important in deciding whether we eat a food or not. The baby's born with the ability to sense all of the taste except salt, which doesn't mature until the baby's about 4 months of age. And if I had to summarize some of the key findings from this body of research, I would say one, children live in different sensory worlds. They like sugar and salt much more than adults do. And I think all of us have witnessed that when we watch a child eat their first taste of their birthday cake. This preference starts to wane during adolescence after periods of maximal growth. The preference for savory taste of amino acids and proteins is also present at birth as well. And mother's milk contains a lot of these amino acids. So you see, again, the baby preferring features of mother's milk, just like the sweetness of mother's milk is also a identifying feature of mother's milk. Now, in contrast, they're born being quite sensitive to bitters and disliking them. And that most likely evolved to protect us from harm, to protect the child from ingesting poisons. They also are born rejecting sour taste, presumably to prevent them from ingesting spoiled food or unripe fruits.
Thank you so much. So you said the child prefers, does not prefer. How can we identify positive and negative responses to the different tastes in the newborn?
That's a great question, and one that I rarely get asked, but one that I have a passion for. So, for much of the work on infants, discoveries are the result of many studies that are using a wide range of measurements. The earliest studies focused on measuring the baby's facial responses that were suggestive of liking or disliking to assess whether when a drop of a solution that tasted sweet or bitter or sour or salty was placed on their tongue. Then, as research developed, other methods were used. They would measure the infant's heart rate while tasting the solution. They would measure how much the infant measure intake, whether the baby would stop crying when they ingested a solution of sweet solution. So all of these measurements with regards to sweet taste, for example, the answers to all of these questions pointed in the same direction, that the newborn was able to detect sweet taste and preferred it.
Thank you so much for this. I wanted to ask you about sugars, but you already discussed it, so I'll jump to the next issue of textures. We learned that to accommodate textures, the oral cavity undergoes pronounced changes during the time of complementary feeding and thereafter. Can you walk us through these changes?
I'd be happy to. So in addition to these age-related changes in taste, where you find that children are preferring much higher levels than adults, and then it wanes during adolescence, we see that there's anatomical changes that are occurring in the oral cavity that are allowing for greater manipulation of foods in the mouth. Some of these changes include, the tongue and the lips become more mobile. The infant develops the ability to move liquids and fluids of varying textures around in the mouth. They can transfer the food from the back of the mouth and then swallow. And we can't underestimate the changes that are also due to the eruption of teeth. They master chewing of food with more complex textures. They're learning to handle foods that are more firm or that are lumpy. So it's really a developmental synchrony between the maturation of these oral skills to be able to process the food and learn about the complexity of texture of food.
Oh, thank you. This is very interesting and important. So texture is important and children are sensitive to food texture. Is it more important in infants and children eating compared to adults?
For all of us, we learn to like what we eat. We continue to learn throughout the lifespan, but the brain appears to be more plastic about learning about foods during fetal life and during these first 1,000 days. They're open to learning not only about taste, but also textures, all of the features of a food, which is a basic biological commodity. What we've discovered is that it's easy to learn to accept new foods or to accept new textures when you're young. It's more difficult, and the motivation may not be there as the child gets older.
Fair enough. So we learned from your article that a wide variety of flavors in the beverages and foods that the mother ingests or inhales, like tobacco, are transmitted to provide flavor to the amniotic fluid and to human milk. What is the evidence for the effect of consumption during pregnancy on food preferences of the infant?
I'm happy to say that the answer to this question is really stems from an international body of research that's shown that the flavors of food mothers eat transfer to amniotic fluid during pregnancy and then human milk during lactation. The evidence is, again, a convergence of findings at first discovering that the child can detect these flavors, and then also measuring amniotic fluid in mother's milk to verify that the flavor indeed changed. While much more research is needed, experimental studies have shown us that experience with these flavors really provides a flavor bridge for the baby. Experience with the flavor of mother's milk is going to make the baby more accepting of a food with that flavor as they explore new foods. This learning appears to be long-lasting. The one long-term randomized controlled study that was conducted in Ireland, and randomized controlled studies are really the gold standard of research that provides perhaps the most definitive answer to this question, revealed that 8 to 9-year-old children whose mothers were randomized to eat garlic during pregnancy not only ate more of a garlic flavored potatoes, but they enjoyed it as well compared to the group of children whose mothers avoided it. So that's perhaps again, it's a convergence of findings, asking the question a variety of different ways, that's showing that infants indeed are detecting these flavors and they're learning about them. It's the first way we learn about foods, long before we ever eat foods, is through our mothers.
Yeah, I could not agree more. Now, we all recommend exclusive breastfeeding, but there are children who are not being able to be breastfed or are partially. Some of them, for medical reasons, need formulas, and cannot consume the breast milk. So another important issue is the type of infant formula that is used. Hydrolyzed formulas and amino acid-based formulas have a pronounced unpleasant taste and odor, and for that end, you developed a model system to explore the long-term effects of consuming cow's milk formulas versus extensively hydrolyzed protein formulas. Can you let us know whether there were long-lasting effects, and if so, what were these effects?
I'd be happy to. The first point is that the formula-fed infant retains information about the flavors their mothers ate during pregnancy. And then as they grow, the mothers and fathers and families are great social models for eating, and they continue to learn that way. Regardless if a baby's formula or breastfed, they learn through repeated exposure. They learn to eat what they're fed. What the babies have told us through experimental research is that while the formulas that are hydrolysate-based may taste bad to you and me, they don't taste bad to the baby who has been feeding these formulas from an early age. We discovered that there was a sensitive period for learning that was then applied to learning about flavors and during breastfeeding, is that the first 4 months appear to be particularly important If the infant was fed the hydrolysate formula during the first 4 months, experience resulted in a greater preference for that formula months and years later. The effects were long-lasting and were evident several years after the last formula exposure. We find that these children who were fed hydrolysate formulas prefer the flavor of the hydrolysate formulas. They'll be more accepting of sour tasting juices, bitter vegetables, and of course the flavor of the formula that they were fed. This plasticity persists, so regardless if the infants were fed formula or human milk, they learn to like a particular food through repeated exposure and through exposure to variety. Infants learn to like what they eat, the foods of their mothers, the foods of their families, the foods that are fed to them.
Excellent, thank you. We also learned that repeated exposures increases food acceptance. Is there a magic number for the number of exposure for food acceptance?
The magic number depends on how old the baby is. The magic number depends on how old the infant is. For young infants, younger than 2 years of age, it takes about 8 to 10 days of exposure. Merely looking at the food doesn't work. The baby has to taste the food in order to learn to like its taste. Now, as the child gets older, it takes maybe 10 to 20 exposures for it took 10 to 20 exposures for toddlers, highlighting the importance of providing this repeated exposure early in life.
Okay, so you answered also the effect of age. And what is the reason for the success of repeated exposures?
And that's a great question that's still a mystery. Obviously, there'd be a change in the brain, but what and how it happens, we don't know. What we do know is that infants learn through this repeated exposure to food, most likely that they begin to associate the flavor, the texture, the taste, the smell of the food with feelings of fullness and enjoyment. And they're learning it also in the context of mothers in a family.
Okay. So coming back to the preference to sweet and later to salty foods, I know also as a grandparent that I admit that this is what they ask for when they come to visit. Is there a way to decrease these likings? And to that end, is being a model for our children by consuming a healthy diet being helpful?
I think now that we know that there are inborn preferences for infants and sweet and salt are particularly attractive, one way I like to answer that question is to really focus on the good news. The good news is that we have a sophisticated biology that leads the baby to be attracted to what they need, mother's milk, calories, minerals. And think of the human's primitive past. We lived in an environment where there weren't added sugars or free sugars or low-calorie sweeteners. This preference for sweet allowed the infant to be attracted to and prefer human milk, fruit. Salt was scarce and not plentiful like it is today. Now, the bad news is, as you implied, is children are extremely vulnerable, more so than you and me, about this environment in which sweet and salt is abundant. My advice to parents and grandparents would be delay, delay, delay. Most medical authorities around the world are recommending no free or added sugar. That is the sugars that are added to foods during processing before the baby reaches 2 years of age. So you can tap into that sweet preferences by providing fruit. After 2 years of age, you should limit this added sugar intake because it's important to realize that intake of these foods are associated with not only higher energy intake, but they're also increased risk of the most prevalent disease of childhood, which is dental caries. And so that's important to make that association, which is a motivating factor for this dietary change. But I would also mention that this isn't just a problem with children. It's a problem with adults too, who are eating too much added sugar. So be a good role model. Don't just think of the child, think of the family, including the grandparents. Getting infants off to a healthy start, as well as improving the diet of the entire family, is the single most important aspect that an individual can do to reduce their risk of disease in modern societies. While the guidelines recommend how much added sugar the child or you and I should eat, they don't tell us how to do this, how to get children and people of all ages to like the taste of foods and beverages low in sweetness. So I apologize because I don't have the answers to this, but I think the answers will come from more research in this area that's needed. The benefits of science in translating the needs of human society, and how do we get babies and parents and grandparents to have a healthy diet.
Yeah, so Professor Mennella, there is so much material in your excellent paper that we cannot hope to cover it all. And I strongly urge listeners to download the copy from the NNI website. So perhaps we can wrap up by asking you to summarize what you see as the key elements that are important for healthy food preferences in infants and toddlers.
Thank you. Knowing that these senses that are so important to identifying the food are plastic and open to learning from an early age, I think one of the key messages is that you can't start too early. Learning about flavors first begins in the context of this dynamic interplay between mothers and children that begin in utero and continue throughout childhood. It's a two-way street. The family's interaction with the child is reciprocal. We're learning from each other, and it's affected by this shared environment that begins in utero when the chemical senses are beginning to functionally develop. I would ask you to reflect on these beginnings and bear witness to the diversity of cuisines around the world. We first learn from our mothers by the transfer of these flavors to amniotic fluid and human milk, and then fathers and families and siblings and peers. They all teach us of what food is safe, what food is preferred, what a food should taste like, what food is available in the environment. And it's probably the most example of the most sustainable behavior because mothers often feed their children what they themselves are eating. The baby's learning about the mother's diet from an early age. But food is much more than a source of calories. It defines who we are, it defines our family, and it defines our culture. And so great importance is placed on learning about foods. So I hope that I shared with you today how babies learn about foods, but also that I shared what we don't know and more research is needed.
Thank you so much, Professor Mennella. This was a fascinating podcast. It has been a pleasure and true honor to have you share your huge experience, and I hope we have another opportunity soon to widen our knowledge and share your vision on a healthier future for children.
Thank you, Dr. Shamir.
Thank you, and thank the audience for listening to this very special edition of our podcast, NNI Bites Big Learnings. Please subscribe to the NNI 365 app to ensure you don't miss future offerings.
And that concludes today's episode. Thank you for joining us with Ranan Shamir and Julie Mennella as we talked about biological and experiential factors that impact the acceptance of complementary foods. We hope you enjoyed and learned from this quick discussion, fellow experts. Till the next episode.